Hi friends, good evening. Welcome to my channel Belagali's class. Friends, already two classes yesterday and day before yesterday started with the inverse trigonometric functions ITF. In the first day I have done about what? About this restricted identities, conditional identities. I have told everything. To make the trigonometric function 1, we have to cut the domain. Restricted in case of sine inverse, cos inverse, tan inverse, everything is explained. Yesterday I have done mainly with what? Idea of inverse trigonometric functions. You have seen above. First, second, third, cot inverse x I made like this. Cosec inverse x, sec inverse x, because I will explain. See my friends, then comes domain. Both are same, side by side. -1 to +1, -1 to +1. It is easy to remember here. Then for tan inverse, cot inverse, see, it is also -infinity to +infinite, -infinity to +infinite. Or you can say that the entire set of real numbers, they are both side by side, only one, if you remember, that is next. Cosec inverse x, see my friends, what is it? It is entire set of real numbers except this open interval, -1 to +1. My friends, this one, what is it? It is +infinite, this is -infinite. In this open interval -1 to +1. This open interval -1 to +1. My friends, its domain is this entire, except that open interval. Except that open interval, my friends. Even it is same for what? Sec inverse x. Writing like this, even if you write like this, it helps you to very well remember. For the sine inverse, cos inverse, what is the domain? Same. If you remember, for sine inverse, it is same as cos inverse. See, for the tan inverse, cot inverse, same. If you remember only one r, it is same for cot inverse x. What about the cosec inverse x? Same. -infinity to +infinite, -1, 1. Otherwise, in this way, same for the sec inverse. My friends, this pair is same domain. For this pair, domain is same. For this pair, domain is same. This is about the domain of this ITF. Now come to the next one. What is it? Range, or another name, principal value branch. It is for the sine inverse -π/2 to +π/2. For cos inverse, the range is 0 to pi. For tan inverse, it is -π/2 to +π/2. For cot inverse x, 0 to pi. For cosec inverse x, -π/2 to +π/2, except one value, that is x equal to 0. For sec inverse, closed interval 0 to pi -π/2, except it is told yesterday at x equal to 2, the functions are undefined. My friends, if you write this horizontally, for you man it is little bit convenient, pair. Yesterday I had written vertically, it is better, I hope. Yes, my friends. Yesterday itself I think I might have done half dozen examples in not finding, just the examiners will mention, write the range of this inverse function, domain of this inverse function. In one model question paper, instead of domain and range, the friend is mentioned principal value branch. Okay, that's why I mentioned that also here. Understood? Yesterday even I have given their appearance in the question paper, main exam question paper. Even once man in CET, I think it is 2017 or 2019, I have not remembered exactly, appeared the range or the principal value or the domain of this inverse trigonometric functions. Below they give 4 options, 1, 2, 3, 4. See my friends, how much important this table. That's why write neatly, attractive. That table must attract you to read it, my friends, because it is important. I make it a star mark here. It is important, my friends. Yes. Yesterday is one type. Today I do another type. These will also come under 1 mark questions. 1 mark questions. Yes, my friends. It is also another type. Examples. 1 mark. 1 mark questions. 1 mark questions. In this man, find the principal value of. Find the principal value. Principal values of the following inverse trigonometric functions, ITF. My friends, these examples will also come under 1 mark. In this part, I may do around 4 or 5 examples. Okay, 1 or 2 examples just for your practice. My friends, see here, values comes. Values means what they are. In this case, you must remember that another table I have given. What is it? Trigonometric values of standard angles. What they are? Sine, cos, tan. What about the angles? 0 degree, 30 degree, 45 degrees, 60 degrees, 90 degrees. Even along with this, I have given allied angle formula to find the values of what? Angles more than 90 degrees, like 120, 150, 250, and like that, more than 90 degrees. That allied angle formula is also given. My friends, now I do some examples based on this. Principal values. If you remember that chart, it is good. Even another way to remember that tabular form very easily. If you want, you can write it, my friends. For the sine, my friends, I start with values. It is 0 degree. It is 30 or pi by 6. 30 or pi by 6. Then 45 degrees, or my friend, it is pi by 4. Yes. 60 degrees, or pi by 3. 90 degrees, or pi by 2, my friends. Radians. I have mentioned both. Degrees as well as radians. This is 30 degrees or pi by 6. Yes, my friends, so these are angles. I write this sine here first. This is for the sine. First man, you write as usual. It is 0, 1, 2, 3, 4. After this, you divide each number by 4. Divide every number by 4. Divide by 4. Divide by 4. Divide by 4. Then you take the square root of this. Square root. It is square. See, my friends, what is sine 0? It is 0. 0 by 4 is 0 itself. What is sine 30? What is the square root of this? 1 by 2. 2 get cancels. What is sine 45? 1 by root 2. What is sine 60? Root 3 by 2. What is sine 90? 4 divided by 4 cancels, gives 1. Even if it goes very difficult, or if you won't remember at that time, you write it easily. For the sine, you start with all these are angles in the increasing. 0, 30, 45, 60, 90. Right, start with 0. 0, 1, 2, 3, 4. Divide, the division is same. Divide each number by 4. Then you take square root, directly you get the values. What about in case of cos? This is about, my friends, sine. Yes. In case of cos, my friends, okay. You start ulta, reverse. Here you start with 4. Start decreasing. There it is increasing. Here it is decreasing. 2. Then 1. What is this, my friend? 0. The same principle. What is it? Divide each number by 4. Each number by 4. Each number by 4. Divide by 4. My friends, then you take the square root. Square root. Then you take the square root. Square root. Yes, my friends. See, what is cos 0? 1. Yes or no? Cos 30, root 3 by 2. If you simplify. What is cos 45? 1 by root 2. What is cos 60? 1 by 2. What is cos 90? 0. My friends, for the sign, remember, you have to start with 0 to 4. Whereas in case of cos, you have to start with 4 to 0. 0 to 4, 4 to 0. Division is same. Divide each number by 4. Later you take square roots. That gives values. And I hope the remaining, my friends, if you wanted tan, you know, sin by cos is tan. Or simplify. Then you wanted cosec, reciprocal of this. You wanted sec, reciprocal of this. You wanted cot. What is cot? Cos upon sin. So like this, my friends, you are very well remember. Still one more shortcut way is there to remember, that you can remember with help of your hand, palm. That I will tell in future, not everything today itself. This is one way of remembering values of trigonometric ratios of what? Different or standard angles. Standard angles. Yes, my friends. Just remember this. Just reminding this, now I do the examples. Examples. Principal values of the following ITF. Yes, friends. The first example is, all these good examples, Sin inverse 1 by 2. All these are from your textbook, my friends. I have not copied any other than your textbook question papers, model question papers is the target. Sin inverse 1 by 2, my friends. I told yesterday itself. What is this? Inverse function is an angle whose sine is 1 by 2. Directly why? I told here itself, I mentioned all these examples comes under what? 1 mark. Very, very precise, very simple. To the point you have to write the answer. So here, what is this? Angle corresponding to this. It is pi by 4 radians. If any student has the allergy about these radians, you are free to write what in terms of degrees. What is it? Sin inverse 1 by 2 is 30 degrees. 30 degrees. It is pi by 6, not pi by 4, pi by 6 or 30 degrees. Even you are free to write in terms of what? 30 degrees. If anybody wanted method, sir, we want more than one line. Okay. There are some students, even some examiners, if you write quick in one word, they are not happy. They wanted what? The detail, how you got it. In that case, I give that answer. My friend, to take this equal to theta, or let sin inverse 1 by 2 equal to theta. My friend, it is a number like between -1 and +1. You are free to use the definition. By definition, sine of angle, sine of theta is half, my friend. Then what is this half? This half is nothing but sine 30 degrees. 30 is pi by 6 radians. Therefore, what is the angle, my friend? Sin theta equal to sine 30. Therefore, theta is 30 degrees. Pi by 6 radians. Hope it is clear. If anybody wanted, sir, I want a little bit more steps. Such a friends, this. There are some friends, they want to the point. What is it? It is an angle whose sine is 1 by 2. What is that angle? 30 degrees or pi by 6 radians. You can write in this way, otherwise in this way if you wanted a method. Alright my friends, next one is sine inverse 1 by root 2. 1 by root 2. Yes my friends, you know, direct write pi by 4, otherwise 45 degrees. If you wanted the method, you know, above it is a dancing, you can use, you can find it. Okay. Next one, cos inverse root 3 by 2. Next one, cos inverse root 3 by 2. Tell my friend, what is the respective angle? In this case it is 30 degrees. 30 degrees. Yes. Next one is tan inverse 1. Tan inverse 1. My friends, I told all inverse functions are what? They are the angles. Okay. In this case what? Tan inverse 1 is an angle whose tan is 1. What is it? 45 degrees or pi by 4 radians. Pi by 4 radians. Yes, my friends, if you wanted one more, yes, right, it is cot inverse root 3. It is cot inverse root 3. Friend, corresponding angle root 3, in case of cot inverse root 3 is what? Small angle. 1 by root 3 is big angle. Sir, what do you mean by small and big? In case of tan inverse, otherwise tan and cot, that root 3 and 1 by root 3, they have what? 30 and 60 degrees. In case of tan 30, 1 by root 3, tan 60, root 3. If you take the inverses, tan inverse 1 by root 3, 30 degrees. Tan inverse root 3 is 60 degrees. But the same in case of what? Cot inverse. Reciprocal means what? Cot inverse 1 by root 3 is big angle, 60. And cot inverse root 3 is small angle, which is 30. Is it correct? My friends, what is this? 30 degrees. In terms of radians. What is cot inverse 1 by root 3? Which is bigger, pi by 3. Pi by 3. Like this, my friends, you can write anything. If you wanted one with cosec inverse 2, my friend, 10. Cosec inverse 2. What is it? Cosec theta is 1 by sine 1 by 2. What is the respective angle? 30 degrees. 30 degrees. Pi by 6 radians. Like this. Sec inverse 2 by root 3. What is cos 30? Root 3 by 2. Reciprocal 2 by root 3. Then what is the corresponding angle? I write, man, this in terms of what? Degrees. My friends, you may write in terms of radians, otherwise in terms of degrees. This is another set, very simple examples. These examples, my friends, you can see in the question paper under 1 mark questions. See friends, this is the second type. Alright, yes my friends. After this comes properties of inverse trigonometric functions. There are 5-6 properties and related examples. Even while doing the properties, those properties itself, theorems itself, important under 2 mark questions. There are some examples based on these properties. They are also 1 mark, 2 mark questions. I told in inverse trigonometric functions you have 3 type of examples. One type, examples under 1 mark. Second type, examples under 2 mark. Then third, examples under 3 marks. 1, 2, 2. They give 1 mark 1, I think 2 mark 2 and 3 mark 2. Alright, friends. Yes, my friends, this is one. Now I will do with the properties of inverse trigonometric functions. Yes, friends, I write here properties of inverse trigonometric functions. Properties of inverse trigonometric functions. Yes, ma'am, there are 5-6 properties are there. If connected, possible, I do the examples related with those properties. All right, friends. First property, I write it as what? P1. What is P? Stands for property. What is 1? First property, like that. P1. Yes, friends. That first property is this. Prove sine of sine inverse x. Sine of sine inverse x equal to x. What about your x domain? Domain for sine inverse -1 to +1. Second, this is 1. This is second. Cos of cos inverse x. Cos inverse x equal to x. For all x, same thing. For all x, same thing. Third one, tan of tan inverse x. Tan of tan inverse x is x itself. Tell my friends, in this case, in case of tan, see here it is r, that's why I have written above. Everything is visible. What is the domain of sine inverse? -1 to +1. What is the domain of cos inverse x? -1 to +1. What is the domain of what? Tan inverse x. It is r. X belongs to r. Even proof is very, very simple, my friends. Very, very simple. I prove one or two. One you have to do yourself. DIY. Friend, let's say in this case, let sine inverse x equal to theta. What about your x? It is well inside domain. Then by definition, x equal to sine theta. X equal to sine theta. Tell my friends, what is theta? Sine inverse x. Just you have to put the value of theta. This, my friend, theta. Above only it is sine inverse x. Theta is sine inverse x. From this, what is clear? Sine of sine inverse x is x itself. Therefore, sine of sine inverse x. Sine inverse x equal to x itself. On the same lines, second, what you have to do? Let this equal to theta, x equal to cos theta. Same thing it will come. Okay? Substitute. Second, let cos inverse x equal to theta. Then by definition, x is cos theta. Cos inverse taking that side, cos. It is a dancing. Cos inverse, cos, my friends. But you can dance only in the compound. What is the compound? -1 to +1, not outside. Alright. Then you have to put the value of theta. What is it? It is cos of theta is cos inverse x. Therefore, what is it? Cos of cos inverse x. Cos inverse x equal to x itself. Like that, my friends, anything, even if it is tan of tan inverse x, by taking this equal to what? Theta, same method. Tan theta, put the value of theta. Similarly, for remaining, what they are? Sec of or cot inverse x is x. My friend, what about x? belongs to R. Similarly, cosec inverse x. What is it? X. What about your x? Domain of x is what? R minus open interval minus 1 to plus 1. Similarly, sec inverse x is also x. What about x? It is R minus 1 to plus 1. Even I told with the help of what? Line. This is, my friends, first property of inverse trigonometric function. What is it? Sine of sine inverse x is x itself. You can use this property under the condition. What about your x? X must be between minus 1 plus 1. If it is other than minus 1 to plus 1, if it is 2 here, you can't use the property. You can use the property when x is between minus 1 to plus 1. Same for cos inverse. When x belongs to R, for tan inverse, this is for cot inverse, cosec inverse, and this is sec of sec inverse x is x itself. This x belongs to what? Entire minus 1 to plus 1 open interval. Yes, my friends, this is property 1. Yes. Looking at the next property. Even, my friends, this you can generalize t. I will go with this itself. What is cos? It is a trigonometric ratio. What is it? It is its inverse, t inverse, equal to what? X itself. That number, whatever it is, if it is x, under the condition. What is that condition? Under the domain you can write what? T inverse is x itself. Is it correct? This is its inverse property. Or you can write here T inverse x. T inverse x is x itself. Yes, friends, this is the first property. Next property, second property. Yes, friend, this second property, just I want to remind certain results in trigonometry. Those results I write it in the form of note here in this corner. Note. Yes, my friend, you know it. Cosec theta, it is just a reminder. What is cosec theta? 1 by sine theta. Even you can write what? Sine theta is 1 by cosec theta. Like this. What is next? Sec theta is 1 by cos theta. Sec theta, 1 by cos theta. And what about cos theta? 1 by sec theta. 1 by sec theta. Like this. Related with cot, 1 by tan. What is tan? 1 by cot. Like that, my friends. These are 3. The next is related with just cot. Have it in the mind. Cot theta, 1 by tan theta. 1 by tan theta. And what about that? Tan is 1 by cot theta. Yes, friends. Related with this, I do the next property. Second property. Prove 1. Cosec inverse x equal to sine inverse. You have to take the reciprocal 1 by x. Then second, sec inverse x. Sec inverse x is cos inverse 1 by x. Third, cot inverse x. Cot inverse x equal to tan inverse 1 by x when x is positive. But in all these cases, what about x? X should not be 0. That domains are there. Is it correct? Yes, my friend. Sec inverse x is cos inverse 1 by x. Cot inverse x is tan inverse 1 by x. Cot inverse equal to tan inverse 1 by x when x is positive values. When x is negative, we have a different one. That is pi plus or minus pi plus tan inverse 1 by x. That I will discuss later. Alright, this is the second property, my friends. Again, same method. What is that? Let any side, either this side or this side, equal to theta. Is correct? Right. Yes. See, my friend. Yes. First one, proof. Let cosec inverse x equal to theta. Cosec inverse x equal to theta. Under the domains itself. Then by definition, x equal to cosec theta. But what you wanted, this x in RHS will convert into 1 by x. Take, my friends, 1 by x. Reciprocal. What is it? Reciprocal of cosec. 1 by cosec. I write. What is 1 by cosec? See there. 1 by cosec is sin theta. Yes, my friend. Therefore, sin theta is 1 by x. Then what is theta? Theta. Take that side. Sin inverse 1 by x. But what is theta? Cosec inverse. Therefore, theta is cosec inverse x equal to sin inverse 1 by x. Yes, my friend, this is first. What is it? Cosec inverse equal to sin inverse 1 by x. On the same lines, we can prove the second. Tell. You have to take what? Sec inverse x equal to theta. Same. Let sec inverse x equal to theta. Then, by definition, x equal to sec theta. My friends, take the reciprocal 1 by x. What is the reciprocal of sec? See there. 1 by sec theta is cos theta. Bring this side, cos inverse 1 by x is theta. Is it correct? Tell, my friend, what is theta? This theta is nothing but sec inverse x. Sec inverse x. Therefore, friends, sec inverse x is cos inverse 1 by x. 1 by x. Like that you can do the third one. Let cot inverse x is theta. X is cot theta. Take the reciprocal. That reciprocal gives tan. Bring this side. Same lines. Therefore this equal to that. My friends, it is second property. Second property. Alright. Yes, my friends. My friends. Next, I will start with the third property. Another very important property. Third property. Yes. Yes. Property 3. Yes, my friends, even this third property, P3, third property also needs what? Just a remind of some results in trigonometry. There is note. What there? See, my friends. Yes, you know this. These are the things you know. What is it? Sine of minus theta, minus sine theta. Therefore, from this, my friends, minus sine theta can be written as sine of minus theta. I hope it is clear. Now, we know sine of minus theta is minus sine theta. Then minus sine theta can be written as sine of minus theta, means this minus can be taken inside. Like that, the second, tan of minus theta. Tan of minus theta. It is minus tan theta. Therefore, minus tan theta can be written as tan of minus theta. Third one, cosec of minus theta, minus cosec theta, minus cosec theta. Therefore, minus cosec theta is cosec of minus theta. Yes, my friends. These are of the same properties, all the three. That's why I collected the same persons, same trigonometric persons having the same property. What is it? Sine of minus theta, tan of minus theta, cosec of minus theta. This minus comes outside. Is it correct? Now I do what? Property related with these three. You may ask what? Sir is not considered about what? Sec inverse is cos inverse, then cot inverse, like that. Tell my friends, what is cos of minus theta? It is not minus here, it is plus cos theta. Totally different concept comes here. In this case, all the three, 1, 2, 3, we can take what? That negative out. I use this. Related with this, I do the property, that is third property. Then connected with the third only, 3a, 3b, I do what? Next property. What they are? Cos of minus theta plus cos theta. Sec of minus theta, like that. Related, I do next property with that. Yes, friends. P3, third property. Prove 1. What is it? Sine inverse minus x. Sine inverse minus x is minus sine inverse x. Minus sine inverse x. Second, tan inverse minus x is minus tan inverse x. Third, cosec of cosec inverse minus x is minus cosec inverse x. Yes, my friends, again method is same. What is it? Let this equal to theta. 1 proof. Let sine inverse minus x equal to theta. Then using definition, then take sine inverse that side. Minus x is sine theta. What about your x? X is minus sine theta. Yes, my friends, we convert this minus sine theta by making use of this. See here, I discussed earlier itself. What is minus sine theta? Sine of minus theta. You can write it as what? Sine of minus theta. Sine of minus theta. Taking to this side, it is sine inverse x equal to minus theta. Therefore, tell my friend, what is theta? Take attach minus to this side. It is minus sine inverse x. Tell, what is your theta? Theta is nothing but sine inverse minus x. That is sine inverse minus x is minus sine inverse x. Yes, friends, this. Is it correct? This is second. Same. What is done? Let this equal to theta. Take sine inverse that side, sine theta. Minus, you take that side. X is minus sine theta. By making use of that property, this minus comes inside. So, again take sine this side, becomes sine inverse x equal to minus theta. Attach this minus here. Theta minus sine inverse x. But what is theta, my friends? Sine inverse minus x. Therefore, sine inverse minus x is minus sine inverse x. Same thing, second. What is it? Tan inverse. Same all steps. Now, if you wanted, I do the third one. That second, do it yourself. Let cosec inverse minus x equal to theta. Then minus x equal to cosec theta. Cosec theta. Therefore, x equal to, you attach that minus that side, minus cosec theta. Once again, the previous property, what is minus cosec theta? That minus comes inside. Cosec of minus theta. Take this side. Cosec inverse x equal to minus theta. Therefore, theta equal to minus this side, minus cosec inverse x. Minus cosec inverse x. But my friends, final step, what is theta? Cosec inverse of minus x. Cosec inverse of minus x equal to minus cosec inverse x, my friends. And this is the third one. All the three, they having the same property, that is, that minus comes outside. Therefore, in this, as a first part, this is the first part of this. I have grouped these three in one. That's how we have done one by one. Even the methods are very simple. These comes under 2 mark questions, man. These, as a theory, 2 mark questions. They may ask. All right. Yes, friends. Another 3. What they are? Sec inverse minus x, cos inverse minus x, and cot inverse minus x. Cot inverse minus x. All right. They need another property. Yes. Okay, friends. Now it is nearly 40 minutes. I will close this session with this itself. And tomorrow, the remaining 3, what they are? Cos inverse, sec inverse, cot inverse. I do those 3 tomorrow, and related examples also tomorrow. Yes, my friends. Thank you very much. Thank you very much. You have any doubts related with all these things, man? Always you are welcome to make your doubts clear. Okay, my friends. Thank you once again.